Okay, so how do we use these double angles? So let's suppose we want the exact value of sine of 75. Now, we don't know the exact value. We know the exact value of lots of things over here, but we don't know the exact value of 75. But 75 is just 45 plus 30. So we can use our formula, sine of A plus B, and write it out. Sine of A plus B is sine 45 cos 30 plus sine 30 cos 45. That's straight from the formula. Sine of A plus B equals sine A cos B plus cos A sine B. Straight from our formula. So that is all I have done there. I've swapped them around, but it is the same. So how do we get sine 45? Remember from our little triangles, these are our set squares that we give our Year 7 students. This is a set square 45, so it's 1 and 1. So this is root 2 using Pythagoras. This is an equilateral triangle, 60, 60, 60, and we've just cut it in half. That's the other set square. So if this is 2, 2, and 2, this is 1, so we can get all our angles from that. So now we've got the sine of 75 is the sine of 45, which is 1 over root 2, plus what's the cos of 30? The cos of 30 is adjacent over hypotenuse times root 3 over 2, plus the sine of 30 is a half, and the cos of 45 is 1 over root 2 adjacent over hypotenuse. So times 1 over root 2. And then we can simplify that. The bottom term is going to be 2 times root 2. And here we've got 1 times root 3, which is just root 3. And here we've got 1 times 1, which is 1. So root 3 plus 1 over 2 root 2. And that would be the exact value of sine 75. If we wanted the exact value of cos 165, we may have to go back to our all stations to central, Cos of 165, or the angle 165 is in here, and that is going to be 15 degrees. So it is going to be the same as 15 over here, but it's going to be a negative because cos is negative over here. So we know it's negative. Maybe write that so we don't forget it. And then we're just going to look at cos of 15. What is the cos of 15? The cos of 15 is the cos of 45 minus 30. And this would give us an exact value. So again, we can write it out. And just as sine stayed the same, sine of A plus B gives us sine A cos A plus, the cos changes. So this is going to be cos 45, cos 30, and the sign changes, plus sine 45, sine 30. And then it's just a matter of writing out what's cos of 45 going up to our triangles. It's 1 over root 2. The cos of 30 is root 3 over 2, plus the sine of 45 is 1 over root 2, and the sine of 30 is a half. So pretty much we're getting pretty much exactly the same thing here. We're going to get root 3 over 2 root 2 for the first one, plus 1 over 2 root 2, and we can simplify that down to 1 fraction, root 3 plus 1 over 2 root 2. Now there's the one thing that we haven't done. Hopefully people understand that. We said right at the start that this cos 165 was over here. That's the cos of 165, so we know it's going to be negative, so we could just put a negative right out the front. Or we could simplify that in a few different ways. But that really, historically, I guess that's exactly why we found these double angles of sine A plus B and cos of A minus B and things like that. Hopefully that clears some stuff up for you. Thanks.